Hi, today we're going to talk about sets. So before we jump into it, let's look at some vocabulary. So a set is a collection of numbers or objects. And if you want to, you could also say that a set is a list of numbers or objects. Each object is called an element or a member of the set. When we write a set, we write the elements within curly brackets. And it's a little funny to draw at first, but you will get used to it as you do it often. So these are what we call the curly brackets. We often denote sets using capital letters. So let's look at an example. It says, if I is the set of IB schools in Charlotte Mecklenburg schools, then I will be equal to, and remember we list them out in the curly brackets. We would say West Charlotte, Harding, North Meck, East Meck, and Myers Park. That's how we will write that in set notation. Let's talk a little bit more into set notation. So not only do we write our list or our collection of numbers or objects or elements in curly brackets, and not only do we denote sets using capital letters, but we also have other symbols that mean other things. So if you see a C with a line in it, or like a curvy E or a curved E, it means is an element of or is in. If you see the same symbol, but you see that there's a slash through it, that means that it is not an element of or it is not in. And then if you see that you have N of A, that means the number of elements in the set. So if we were to have an example and we say that if P is equal to all of your prime numbers that are less than 10, then we will be able to say the following things. We will be able to say, first of all, that P is equal to the following numbers. We already know that a prime number means that a number can only be produced by taking 1 and multiplying it by itself. 1 is not a prime number. 2 is the first prime number. Then we have 3. Then we have 5. And then we have 7. So that's how we write out the set. There are other things that can come out of this set. I could say that 2 is an element of P because I see 2 here. I could say that negative 14 is not an element of P because negative 14 is nowhere inside of this set here. Negative 14 is not in there. And then, last but not least, I could say that the number of elements that are in the set, and instead of me using A, I'm going to need to put P. So the number of elements in set P is equal to 4 because you have 4 numbers, 1, 2, 3, and 4. So now let's get into finite and infinite sets. So a finite set means that the number of elements in a certain set, we can call it set A, has a particular value. In other words, it has a countable amount of elements. An infinite set has an endless number of elements. All right, next we have equal sets. Equal sets have exactly the same elements. For instance, I have the set 7 that has the elements 7, 0, and 4. That is going to be equal to the same exact set with 0, 4, 7. It's the same elements. It is just reordered. Okay. Next, let's look at subsets. It says set C is a subset of D if every element that is in C is also an element of D. and we write it as C being a subset, that's the symbol for subset, of D. What that means is, if I look at the example below, for instance, if I say that C is the set of the numbers 3, 5, and 7, and then I say that D is the set of all odd numbers, then I know that C is inside of D, which means that C is a part or a subset of D. All right. We also know that C is a proper subset of D if every element of C is also an element of D, but the key thing here is that C cannot be equal to D. And we write that as C is a proper subset of D. Notice when we have like less than or equal to, greater than or equal to, we normally have this line here. We don't have that here because C is not supposed to be equal to D. So if I say a regular subset, it is, as long as C is a part of D, whether it's only a part of it or it's the entire thing, they are subsets of each other. But to be a proper subset, you just have to have a little bit of elements from the entire set that you're a subset of. So you cannot be equal to with a proper subset. The next thing we're going to talk about is an empty set. An empty set contains no elements. It is denoted as a 0 with a slash through it. And of course, you can write it in curly brackets, or you can write it in the empty curly brackets with nothing in between them. For instance, it says the set of perfect cubes between 10 and 20 is an empty set. Perfect cubes are numbers that you can that you get from taking a number and multiplying it by itself 3 times. So 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. So there are no perfect cubes in between 10 and 20. So we would call that an empty set. So let's look at some examples. Let A be the set of letters in the word mathematics and B be the set of letters in the word match. The first thing that we need to do is list the elements of A and B. So I can say the elements of A would be M, and I'm going to keep track of them because we don't have to write them twice. A, T, H, E, I, C, and S. So I just underline them to keep track. We do not have to write the repeating letters. Just write it once. The elements of B are M, A, T, C, H, because none of them repeat. So B, it says, find the number of elements in set A. So the number of elements in set A, you would count up the list of the type of letters. That would be 1, 2, 3, 4, 5, 6, 7, 8. So the number of elements in set A is 8. The number of elements in set B is 1, 2, 3, 4, 5. So for part C, we need to decide whether these statements are true or false. So it is said that T is an element of B. We see that T is an element or a member of B, so that is true. For Roman numeral 2, it says S is not an element of A. S is not an element of A. So we see that S is an element of A, so this is false. All right. Roman numeral 3, it says A is a subset of B. That means every element in A can be seen in B. that is false. And Roman numeral 4 says B is a proper subset of A. That means that every element in B can be seen in A, but it cannot be equal to A. So that is true. All right, so that is our video on sets. Hope it was clear and concise. If you have any questions, let me know and I will be free to help you. Have a nice one.